Hey y'all, I'm going to do your homework problems. We have quite a few of them to do today. If we run into a duplicate type, I most likely will skip it. There's a lot of problems, but not a lot of you put them up. So hopefully everyone's watching this though. Okay, so we're going to start with lesson 43. Lesson 43, the topic of that lesson, well, I turned there, was the sine, cosine, tangent. No one really asked questions about those kind of problems, though, except for 43A and B. So 43A and B are purely calculator problems, and we probably didn't talk about those very much. 43A says find 4 cosine of 75.8 degrees. Now I tried to get everyone's calculators in the right mode, so hopefully I did that. So you just want to put in your calculator, you just want to push 4, and then you're going to push cosine, and then you're going to press 75 point, you're going to put in 75.8 and push equals, and your number should pop out. So if I do that, 4 cosine 75.8, out pops a number 0.98. You can round it to 2 places unless they say otherwise. So B is exactly the same thing. You're just going to push 6 sine of 37.42 and that will be your answer. So pretty easy ones, right? Okay, the next one is a distance problem because we must do a distance problem every time. It's number 5 in your book. So let's just scoot down here a little bit. This is lesson 43, number 5. And it says Connie was 20 miles ahead of Larry. So this is the distance Connie. And this is the distance Larry. Connie was 20 miles ahead. Right away, you're going to write your little equation. 20 plus distance Connie equals the distance of Larry. It took adding 20 to Connie to make the distances the same. And then let's just factor these out. Rate Connie time Connie equals rate Larry time Larry. And let's go get some information. It says the time, if he caught her in 5 hours, that means both of their times because she's starting here, he's starting here, and their times are going to be the same, so the time is actually 5 miles. And it says the rate of Larry is twice the rate of Connie. So look at that. We have finally a boy going faster than a girl. That's interesting. Okay, let's just plug all that in. So we have 20. The rate of Connie is what we're leaving in there. Whoops, I forgot the twice Connie. Twice Connie. Rate of Connie. Time of Connie is going to be 5. Rate of Larry is 2 rate of Connie's, and the time again is going to be 5. And so we get 20. Let's just do the next step. 5 rate of Connie equals 10 rate of Connie. So we have 20 equals 5 rate of Connie. And so we get the rate of Connie is equal to 4, and the rate of Larry is going to be 8. The time is 5. We want the distance of Larry. So the distance of Larry equals rate of Larry, time of Larry. So we get 5 times 8, and we get 40 miles. So if I went too fast on that, you can rewind it as many times as you want and watch it again. All right, let's hit the next one. The next one is lesson 43, number 13. Let's see what that is. Okay, tricky one, really tricky, good question. These are hard. So lesson 43, hopefully everyone's watching this, number 13. This one's difficult because the numbers that we're going to get are irrational numbers. Yikes. Okay, so these are our triangles. I'm going to separate them right away. I did the big one first, so let's do the smaller one. When you have overlapping triangles, it's really helpful if you separate them. There you go. All right, I find it really helpful anyway. So we have our right angles right here. So we have our sides of the little one is going to be 7/2, 4, and A. And the big one, you have to add these together. It's a plus c, b, and then we're adding the 4 and 2, and we're going to get 6 down here. So you're going to do, first thing, when you have two sides of a right triangle, you can do the Pythagorean theorem to find the third side. So we need to find the hypotenuse. So a squared plus b squared, so leg squared plus leg squared equals hypotenuse squared. So 4 squared plus 7/2 squared equals a squared. So a little bit complicated, so we're going to get 16 plus 49 over 4 equals a squared. Yeah, you can see why it's just slightly difficult here, right? We can find the common denominator. I actually added these in my calculator. So we get 113 over 4 equals c squared. And our goal was to find c. So we're going to get c equals the square root of 113 over 2, because the square root of 4 would be 2. Normally when you solve an equation like this, you do plus or minus, but we're talking length, so we're only going to have the positive one of the two answers. So now we have a equals the square root of 113 over 2. All right, now we're going to start using ratios to find the missing parts. So I'm going to start with b. It's just a little bit easier. So we would do a ratio 6 over 4 equals b over 7/2. Actually reduced my ratio. I made it 3 over 2 equals b over 7/2. And then you're going to cross multiply across this way, so you're going to get 21/2 equals 2b. Divide both sides by 2, which is the same as multiplying both sides by 1/2. So we're going to get b equals 21 over 4. So we have 2 of our answers. We still have to get that third mean answer. It's kind of a tough one. All right, so now we're going to use the same ratio, 6 over 4, because these are the two that we have. And I'm going to reduce it, so we're going to say 3 over 2 equals. Now this side is a plus c, but we know a is the square root. Remember, this one's the square root of 113 over 2. So I'm going to put that where the a is. So square root of 113 over 2. Let's see how I did that. 3 or 4, square root of 113 over 2. That's going to go up here over, I know it's not pretty at all, over the square root of 113, plus c, over the square root of 113 over 2. Did I leave enough room? I have a little bit more space. Okay, so then we're going to cross multiply. This is a complex fraction. It's a fraction in a fraction. This whole thing is in the top. That makes a difference. So I'm going to cross multiply. So I'm going to get 3 square root of 113 over 2, because I'm multiplying that. And then on this side, I'm going to get 2 square root of 113 over 2 plus 2c. Because I'm going to distribute that through. So I'm taking the 2 times both of these. All right, next, I think what I did was I multiplied everything by 2 to get rid of the fractions. Seems reasonable, right? Everything by 2. So it's going to be 3 square root of 113 equals 2 square root of 113 plus, we have to multiply everything by 2, 4c. And then if I subtract 2 root 113 from 3 root 113, I'm going to get, still have room? I do. We're going to get 1 square root of 113 equals 4c, and we're going to divide both sides by 4, so we'll get c equals the square root of 113 over 4. So that is what we got. So that's our c. Looks like we already got c. What was that? This should have been an a. That should have been an a. Sometimes when I write, the lines disappear. All right, or I just did that wrong. Okay, that was a long one. So there's another one like this. We're not going to do it because it's really similar and these are really long. All right, wipe these out. Let's move on. I think it's number 17 is our next one. This is just this is lesson 43, Find the equation of a line. We have to get these down, guys. So lesson 43, number 23. So find the equation of a line that passes through the point -2, -5, and has a slope of -1/7. All right, so we need to find, we have an equation of a line, we need to find, we don't know the y-intercept. In order to write an equation of a line, it needs to be in the form y equals mx plus b. All right, we have this slope, but we need to find the y-intercept. So we're going to use the point that they give us, which is x and y, and put them in for the x and y, put the m in for the -1/7 in for the m, and we'll find the b. So here we go, -5 equals -1/7 times -2 plus b. And we're going to get fractions. So we get -5 equals 2/7 plus b. And you can use your calculator to subtract, which is, I'm not going to do that. I'm just going to use, this is going to be 35 sevenths. I just like to change it right away. So we're going to get -37 sevenths equals b. So we subtract that, so we get, then we write our equation, y equals mx, m is -1/7, x minus 37 sevenths. So I'm going to check that answer as well. And that is correct. Okay, there we go. Oops, expanded on me. Okay, so wipe that one out. Let's go on to the last one of this lesson, which is number 20. Nope, we have to do 25. All right, we can do it. Okay, number 25. There's two of these as well, so I'm just going to do one of these scientific notation problems. So this is still lesson 43, number 25. So we have to write these. These are estimation problems. So it's going to say estimate 47,816 times 10 to the 5th times 4,923 times 10 to the -14. And that is all over 403,000. So the estimation problem, you're going to get it down to, you're going to round each of these numbers to one number, one non-zero number. So that's the first thing we're going to do. We're going to take the 47,000 and we're going to make it into 50,000 times 10 to the 5th. You can kind of skip some steps here, but let's not do it on this problem. So we get 5,000 times 10 to the -14, and then it's all going to be over, we're rounding it again, 400,000. All right, now we're going to put each of those numbers in scientific notation, which is just a whole number. So it's going to be 5 times 10 to the, we're moving it over 1, 2, 3, 4 places. So we are adding when we move it to the left. So it should be 10 to the 9th. And then we're going to have 5 times 10 to the, we're moving it over 1, 2, 3 places. I think that's a 14, or is it 11? Hold on, let me look in the book. Can't read my writing. It's a -14. Okay, so we're moving it over 3 places, so it's going to be -11. We are adding 3 because we're moving to the left. And then in the denominator, we're going to have 4 times 10 to the 1, 2, 3, 1, 2, 3, 4, 5. So it's going to be 10 to the 5th power. All right, now we're going to multiply the numbers together, the whole numbers together, and we get 5 times 5, which is 25. And we're going to add the exponents because when you multiply with the same bases, you're going to add exponents. We get to the -2 power. The denominator, we get 4 times 10 to the 5th. Okay, at this point, even though this 25 has 2 numbers, you're going to do a division problem. If you change it into 3.30, it doesn't work. So we're going to do 25 divided by 4, and we get 6.25 times 10. We're going to subtract the 5, right? When you divide, you subtract the exponents. And then finally, we're going to get rid of these, and your final answer is 6 times 10 to the -7 power. 6, times 10 to the -7 power. There we go. And we just have one more problem for this lesson, which is number 27. All right, so this is lesson 43, number 27. This is an oldie. So it's 3 over x plus 1 minus 2 over x squared times x plus 1 plus 3x plus 2 over x squared minus 1. All right, you have to factor all your denominators before you can start adding these together. This is an algebraic expression, or they would call it a rational expression because it has fractions in it. You cannot get rid of your fractions. Only if there's an equation can you get rid of them. So we're going to find a common denominator, which is x plus 1, x minus 1, and we also have this x squared. There you go. So then you multiply the top and the bottom times what is missing. This one's missing an x squared and an x minus 1. This one is missing the x minus 1. And this one is missing the x squared because it has the plus or minus. So we just distribute it through. So we get 3x to the third minus 3x squared minus 2x plus 2 plus 3x to the third plus 2x squared. And the final step is you're going to combine the like terms. So we have 3x cubed and 3x cubed. That's 6x cubed. We have negative 3x squared and 2x squared, so that's negative x squared. And let's see, then we just have negative 2x plus 2. I always cross them out so that I make sure I don't miss anybody. And all over x squared times the quantity x plus 1, x minus 1. All right. That was kind of the worst lesson. So let's move on to the next lesson, which is lesson 44.